Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to do the Prelab presentation on the distillation column. So we start off with the background theory. Distillation column will be used for the process to separate a liquid or vapor mixture of two or more substances. Distillation column are vertical towers that contain a series of plates that allow for an increase in the vapor-liquid interface, which leads to better separation. The column in this experiment will be set to run at total reflux. This means that all the top products will be condensed and fed back into the top of the tower and allowed to flow down the column. So overall, no top product is taken out of the system. So the objective of the experiment is to determine the high equivalent theoretical plates HETP at total reflux, and also to determine the effect of liquid and vapor loading on the HETP at total reflux. So this is the process flow diagram of the experiment. So as you can see here is the distillation column, and inside here is the plates for the tray, which where the liquid vapor interface occur. So we continue with the procedures. First, ensure the reflux control is at 0, which is set for the total reflux at the control panel. Number 2, in the PC, set in the man mode, then set heater power control and V to 50%. Ensure the set point of reboiler temperature is 50 degrees C and set point value also in 50 degrees Celsius. Number 3, as the top column temperature sensor TT113 and bottom sensor TT102 reach steady state, record the temperature at the trace at the top and the bottom column. Number 4, collect the sample product at top valve V11 or V16 and also at the bottom which at valve V9. Make sure all the remaining liquid in the sampling valve V9, V11 and V16 are removed. Number 5, to collect the top product sample, place the beaker below above V11. Set the reflux divider to position 1, which is for total distillate. Then open V11 to collect enough sample top product. Close back valve V11, then set reflux divider back to original setting, which is at 0 for the total reflux. Number 6, to collect bottom product sample, partially open valve V32 to allow product sample flow through bottom cooler. Then close back the valve V32, place the beaker below valve V9 and open the valve V9 to collect enough sample bottom product, and then close the valve V9. Number 7, record the refractive index RI of the product samples into data table. Number 8, switch off the heater, wait approximately 10 to 20 minutes and allow the distillation unit to achieve new steady state and drain all mixture into the top and bottom tank. Number 9, repeat for different liquid and vapor loading. By adjusting the heater power and V at 50%, 75% and 100%, repeat steps 1 to 8 for different MVs value. Number 10, turn off the heaters at control panel. Monitor the temperature drop in the reboiler TT102 until 50 degrees C. Then close all the valve V25, V26, V27s and water supply. Then shut down the PC and switch off the main switch in the control panel. So how to obtain the data or results? So to obtain the temperature, we should record the temperature at the trace, which is at the top and the bottom when it reached the steady state condition. To gain the refractive index, we must record the value of refractive index using the refractometers. So what data is not available to proceed and how to obtain it? As you can see in this table, that the data that's not available is the mole fraction of the distillate and the bottom product, and also the HETP value. So for the for HETP, we must use the formula, which is effective column height divided by number of theoretical plates. So formula that can be used to obtain the end result. So we can use the compositions formula to get the mole fraction, which is the formula is actual sample composition weight percent equals to diluted solution composition weight percent times solution weight divided by sample weight. And to gain the theoretical tray, we can use the McCabe-Thiele method, which is y equals to alpha x divided by 1 plus x alpha minus 1. So the expected result that we should gain from this experiment is we must get the minimum number of theoretical tray. This is because this is the total reflux experiment. So when it's in total reflux, we must obtain the minimum number of theoretical tray. So when we plot the graph, we can see that the graph will become like this, and the stages we touch the curve and also the 45-degree line. So I think that's all for me. Thank you.